Good morning, good afternoon. Today we're going to be talking about linear functions and exponential functions and comparing them with each other. This is part of Unit 1, Lesson 2. So we have at this top row right here, we have our general forms of our linear functions and our exponential functions. The general equation just means you have a y equals, and it looks kind of like most of the equations you've seen. We have an x and a y, and then we have what's called function notation. Function notation means that there's a letter that's given to it. A lot of times it's given an F or a G or a H. In this case, this is F. And F of x, and x tells us that the variable in the equation is going to be an x. So when we have a linear function, it looks like an ax term. So you have an x term and then sometimes a number out by itself. An exponential function, when you have an exponential function, that means the x is in the exponent and you're using multiplication. So variable is in the exponent for an exponential function. That's an important piece of information. So a right here, a, we call that the coefficient of x, the coefficient of x. And the coefficient of x, a, that represents our rate of change, okay? That represents our rate of change, okay? And for a constant and for a linear function, that's going to be constant, all right? Meaning that it's always the same. All right, some other words we use to describe that letter are the a. Also, sometimes when we're going to graph, we talk about that a being the slope. Okay, the slope. B is the number that's by itself. We have a couple things that we call that. So that's called, a lot of times in our problem, our initial or start value. Okay, our starting value. And in context of the problem, when this shows up in the problem, this is our y-intercept, where we cross the y-axis. Okay, so that's kind of what those letters represent. And we have the same letters a, b, and x are in our exponential functions. So a is it's different because a is not the number that's attached to the x. So in this case, the number not attached to the x represents our start value. So we can actually, I know you guys might need to pause the video to write this down, but this is our initial, a is our initial, our starting value. B, I like to call B, it represents a kind of rate of change, but I like to call B the multiplier because that's what we're multiplying by, multiplier. And we'll take notes on how this is either like a whole number or it's like 1 plus a percent or 1 minus a percent. Okay, a little bit later. And then X represents our time, so for how long. So X usually represents like a time period. All right. Okay, so that's what we have there. Now I want to discuss kind of the rate of change, okay, and our multiplier, and how those affect what the graph looks like, okay? So let's start off with our linear functions here. If you have the rate of change, so if A, okay, if A is positive, okay, so if A is positive, then what we know is that the graph, okay, then the line has a positive slope, okay? So the graph is going to be increasing or going up. So if you're going to draw a little picture of your graph, and you could draw one on your paper, it doesn't need to be huge. Let's say this is our graph. Ooh, there it is. Okay, our graph, our line is going to be going up, okay? Something like that. Now it could be increasing fast, steep, right? As long as it's increasing, okay? It can kind of look like it could be shallowly increasing, but as long as it's going to be increasing. Now, if we take all this and we switch it around, so we said instead of A being positive, let's say A is negative, right? So if A is negative, and again, you might have to, ooh, that looks ugly. Okay, so you might have to pause your video to rewrite this. So if A is negative, A is negative, then we have that the line has a, oh, I don't want that. Then we'd have that the line has a negative slope, okay? And that just means that if we're going to look at our graph, and you can draw a little baby picture of a graph right here. Let's see, is our graph, ooh, right? The graph is going to be going down, all right? So it could be going down kind of in a shallow way, or it could be very steep. It just kind of depends on what that value of A is. All right. Next up, let's talk about this this right here, okay? So let's talk about increasing and decreasing function. Okay, so going back to those words that we talked about before, this is increasing, I'm going to just put an INC, increasing, INCR, because it's increasing. All right, and this would be decreasing, D, E, C, boom, R, boom. Okay, so the next up here we have our multiplier. So our multiplier tells us, is our graph increasing or decreasing? Now the multiplier works a little bit differently. So the first case we have is, let's start with the smallest case, is we have B. B is between 0 and 1. Okay, so we can write that as 0 less than B, less than B, less than 1. And basically this just means that it's a decimal or a fraction between 0 and 1. And if that happens, then that actually means that our graph is going to be decreasing. So if we were to draw a little picture of a graph, okay, an exponential curve, our graph, and I can't use a line here because it's decreasing, our graph would be going down from left to right. It would be going, wee, it's going down, all right? So we would call this, and we would call this decreasing, decreasing, right? And in this case, it would go rapidly and then slowly. All right, our next situation here, we have an exponential function, is B. B is more than 1, okay? Because if you multiply by something more than 1, then you get a much larger number. Try it out. B is more, then we write that B is more than 1, and our graph is going to look like from left to right. So I'm going to draw a little picture of my graph. Boom, boom, boom. Our graph is going to be going up. Ooh, it's increasing. So let me write that down. That's important. So it's increasing, and we talked about how this is increasing at a slow rate and then rapid rate. It's kind of increasing slow and then fast, 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 fast. All right, so now we have some examples. All right, we could kind of look at. Okay, this is a graph of a, we could just fill in what this is. So going from left to right, I notice that it's going up, so we'll call it increasing, an increasing line, okay? Actually I don't like that because down here, that's where we have increasing from left to right. So I think what I'm going to do is I'm going to pause this and I'm going to erase that. So we're just going to call this increasing from left to right. And on your paper, we could just say this is a line with a positive slope. Okay. All right, and we're going to talk about these next three in a bit. Okay, our next line right here, we notice from left to right, it's decreasing. It's going down. So we're going to call this decreasing. Let's type it. Oh, that's huge. Okay, let's do this. Decreasing. Decreasing from left to right, and we're just going to describe this. We'll just say this is a line with a negative slope. Okay. All right, next up, we have two graphs of exponential functions. So you notice that they're kind of not increasing or decreasing at a steady rate. So this is an example of, we're going to go back up to the top of our notes in a second and write this down. But if it's decreasing and it's going down like this, we have a special word for it. It's called exponential decay, meaning it's declining, it's going down. It's called exponential decay. That's the word we can use. And we would just say that this is decreasing from left to right. So I'm just going to put that right here. You might need to pause the video to make sure you get caught up on that. So that's an example of exponential decay. All right. This next one, this is a graph. It's an example of exponential, the opposite of decay. We would call, this is called exponential growth because it's growing from left to right. It's going up. And we call this increasing, increasing. All right, so make sure you get caught up on this. You might need to pause the video to make sure you got all those keywords down. And we're going to go back up to the top and we're going to write down what is exponential decay and what is exponential growth. So let's go back up to this right here. So if we had two situations, one B is between 0 and 1, it's decreasing. I'm going to write right in here that this is called exponential decay. I'm going to write that in here, okay, because it's declining, it's going down. That's kind of an important kind of key vocab. And if it's going up, if it's increasing, I can copy this. Copy, paste. All right, I'll type it in again. Okay, it's called exponential growth. Exponential growth. Okay? So those are kind of some key things you want to make sure you have down in your notes. Let's kind of just take a look and see everything we should have. So here it is, all right, on our note sheet. And once you have that done, you can go ahead and you can work on the activity on the back of this worksheet. All right, have a good day.